Welcome back again. In this video, I will demonstrate a priority queue structure. Now, unfortunately, the PowerPoint slides don't have any good pictures of a priority queue, so I'll just try to take you through it with a coding example. But the main thing to know about a priority queue, as opposed to a heap, is that it's a collection of items, but each item is a pair. The author refers to it as a key and a value, kind of like a dictionary, although we're going to use a list. But the key thing, I would say the key is more like a priority. So you're assigning like a priority to each item. You're not just going to have a value. Each value has a priority associated with it. So here in the code, I have an example of this. Here I'm creating a node. As you can see, we have a value. There's two parameters. And a priority. Priority in this case, I'm going to say, is a numeric value where 1 has the highest priority. So the smaller the priority value, the bigger the priority. 1 means you're number 1, highest priority. Okay. We're going to use a list, as you can see here. We're not going to make a linked list out of this or a tree, but keep in mind we are going to put this list in order of priority, meaning the highest priority item will always be first in the list, and all other items in the list will be ordered by priority. So here's what we're going to do. To insert a new node, first we see if we have an empty list. If the length is 0, well, we need something in there, so call the append method and put the new node in the list. As you can see, if we get here to this else, that means the queue is not empty. So we're going to use a while loop to find the proper place to put the node. I've created two variables. One is going to be index. That'll be the index of where the node eventually goes. And I've also got a Boolean variable called stop the loop. That'll get us out of the loop when we need to. So as you can see, I have my while loop here while the index is less than the length, and while stop the loop is false, meaning don't stop the loop yet. Here's what we're going to do. So the node has been created. We'll say if the node's priority is greater than or equal to the priority at index, then increase index by 1. That means that's not where it needs to go further down the list, so increase it by 1. If we get to this else, that means that this condition right here is false. That means node's priority is not greater than or equal to index's priority, so stop the loop. That gets us out of the loop. And once we're out of the loop, we check this. If index's value after all this is equal to the length, meaning obviously the new node has the lowest priority, then just append it. Put it on the end of the list. Else, if that's the true, if the condition is false, if we get to this else, now that means it fits somewhere else in the list. So we're going to call the insert method with the value of index and the current node and put our new node into the list at this index. This insert method right here is the built-in insert function for lists. I did not need to define this insert function. It is built in with lists. And it takes two parameters. It takes the index of where you want to put something and the something, whatever it is you want to put into the list. Now, just like a heap, however, we're going to remove the root. You probably can remove other nodes from a priority queue, but we're just going to do the root. So once again, I'm going to use the good old pop function from a list, but notice I don't leave the parentheses blank. I have a 0 in there. Well, the root is always the very first element. That would be element index 0. So we're just going to pop it off of there. And we're going to put it in a variable called see ya. And I'll just put a little message saying we removed it, the value with its priority, and then return it. And then finally, I have a display function that will just use a for loop to display every element of the priority queue with its value and priority. All right, so let's run this code. Here is main. So as you can see, the first thing I do is I create an object of the priority queue class, and I'm going to insert 4 nodes. I decided to use names of baseball teams for the value and give a priority, which just I came up with something. So notice I'm doing Angels first with a priority of 5, then Dodgers, which has a priority of 2, then Giants, and then Padres. Keep in mind, though, this is where I'm adding them in the main program, but once they're in the priority queue, they should be then ordered by priority. Highest priority first, lowest priority last. So if I run this program, here's what I get. So the result of this initial lines of code is right here. This becomes this. And notice, even though I inserted the nodes in this order, look at the order they're displayed. Dodgers comes first because it has the highest priority. Then Angels, then Padres, then Giants. You see how the nodes were put in order of priority? That's a priority queue. Next, we remove the root and display again. So here it says I removed the value Dodgers with priority 2, and here's what I'm left with: the Angels, the Padres, and the Giants. I remove the root again and display, and I get this. Angels gets taken out. We're left with Padres and Giants. Now, I'm going to insert a node. Let's say I insert the Mariners, and they have a priority 9. Well, here was the priority queue before the Mariners got in. After they get in, here's what we have. Here's the Mariners right where they're supposed to be, between the Padres and the Giants. Furthermore, then I insert the Rockies with priority 7. And here's where the Rockies are at the very beginning of the priority queue. And finally, we insert the A's with a priority of 57, which obviously means the A's are the lowest priority, and that's why the A's are at the bottom or last element of the priority queue. So there you have the very basics for doing a priority queue. If you have any questions, please send me an email at kmuldrow@lbcc.edu.